as a part of this project, we're improving both the health of the forest alongside the stream and the stream. So prior to the restoration, really lots and lots of invasives, lots of trees, native trees that were diseased, dying, falling into the channel because of instability. So we're trying to recreate a healthier and more native forest here, which is very important for habitat, but also helping with water quality for the stream channel. Prior to the restoration, this site, this stream reach, which is Meadow Creek, and it extends about 9,000 feet of stream, so almost 2 miles. This stream reach was exhibiting a lot of degradation issues. So the main one was very, very steep, eroded vertical banks, in some areas as high as 10 feet tall or more, that were just completely raw and exposed dirt. This was resulting primarily from stormwater runoff coming from the watershed, causing high volumes, high velocities of water in the channel, and really just causing those banks to be carved out by these high waters and also eroded down. So we had large piles of unconsolidated sediment that in essence were burying the stream bottom and pretty much making it a real challenge for much aquatic life to get a foothold here.
Meadow Creek is that blue line through the middle, the orange line is the city limits. And that blue area is essentially the drainage area to Meadow Creek, so it's 5,800 acres, of which, again, at this point in time, most of it is built out. It's mixed residential, commercial. We don't have a lot of industrial in this particular area, but historically, a lot of this was agricultural land.
You can imagine this stream, way back when, was just a small little channel flowing through the woods, and as the watershed developed and things changed, the water that the stream was carrying, again, increased in velocity, increased in volume. So the idea with the channel restoration was to help the stream to become stable in this sort of new watershed setting. So to do that, there was work done to add meanders in some locations. There was work done to shape back those really, really steep banks to allow the stream to actually access the floodplain, whereas before, with those steep 10-foot banks, during high events, that water was just trapped in the channel, kind of exacerbating the problem. So the banks were sloped back so the waters can actually access the floodplain and slow down, and energy is dissipated. The stream designers, they do extensive modeling and field data collection to try to figure out what would be the most appropriate, pattern. Where should the meanders be? Where should the straight parts be? How big should the bends be? How tight should they be? So they look at every single aspect of that. And they do have to take into account the existence of utilities and other things to try to work around those.
This scale of stream restoration is a giant construction project, and it uses giant equipment, and you could sit there just for hours and watch these trucks drop off 5 rocks, and they're the trucks that seem to fill up the size of this room. It's just, I think, somewhere between 8,000 and 10,000 tons of rock that were brought into the project, but it was called a zero balance project where no soil was taken out of the project corridor. So as stream channel was being moved, you needed to fill in those areas. And in some cases, some of the floodplain area, it was designed in to have more topography, either small mounds or depressions, things to bring some more variation into the system. So they were able basically to lose all material on site.
So it's a holistic approach, looking at the whole, almost 2 miles. They try to figure out, again, where that pattern should go, and also along that pattern, where are there areas where we might want to install an in-stream structure, is what they're called. This is actually an example of one. This, if you see the rocks that are placed in this channel here in kind of a V-shaped pattern, this is an in-stream structure. It's called a cross vein. And the purpose of this is to help direct flow to the center of the channel, and also to help control the grade. So as the stream is dropping down, we have these in place every now and again to help ensure that the stream bed doesn't cut down too much. And you can see it's functioning quite well. All the water, for the most part, is directed towards the center of this. And during a high flow event, the water goes up these arms and spills down back into the stream versus, cutting away at the stream.
And it used to be before, if you have a big rain event, it was like muddy from left to right bank, just consistent muddy from one side to the other. Now you see the water roaring through across this vein, and it's got like white caps down the middle, and the plants on the side aren't moving, which is the intention is it really just directs all that energy down toward the part where it's going to do the least damage to the system.
There are also features called root wads, which are basically the root ball of trees that is built into the side of the channel the root ball, the trunk of the root ball may extend 5 feet or more into the stream to keep it in place. They serve to help, in addition to the live stakes, stabilize the stream banks and help to also provide habitat. They make little nice nooks and crannies for fish to hide out in. This whole section was quite straight prior to the restoration, but you can see, there is a nice pattern throughout here, which again helps to slow energy. As if you imagine driving down a highway, you can go really, really fast, but when you're on a slow country lane with curves, you got to slow down. That's what a normal healthy stream does, and that's what has been recreated here. On the stream banks, what we've done is planted, in addition to a lot of herbaceous species, little plugs of plants, we've planted quite a few of these live stakes, which are these stakes that you see all up and down the corridor on the stream banks. They are willow and alder stakes. They're actual live cuttings from existing plants. And the point of planting these is that they are excellent for stream stabilization. So they grow really fast. They have these very dense fibrous root systems that help to hold the soil in place. And really they're just great for these types of settings. And you'll see them all up and down the corridor, all these little stakes. And they, again, in a few years when you come out, you will see them just very bushy and really taking a good hold on the banks.
In May of this year, we didn't do the ribbon cutting, we actually did a vine cutting. So we had a big grapevine and the counselors went with loppers and cut the vines up.
1, 2, 3.
There are a lot of studies, whether they be scientific studies or some of the planning studies, some of the TMDL studies that have really pointed at a need to decrease sedimentation in that system to improve the stability, improve habitat, enhance the forest, protect infrastructure, and then create these education and research and recreation opportunities. So there's this definitely long-term involvement with the team. So it includes physical monitoring of structures, whether that stable system is in fact what they're seeing over years, both the stream channel and the vegetation. There'll be ongoing monitoring of the benthic community. We've already got folks who have adopted stretches of the stream, so that comes with it comes an obligation to do at least 2 formal pickups.
But this is a significant stretch. I mean, being able to restore, almost 2,000 feet of stream and have substantial forested buffer along each side, plus this whole corridor is permanently protected, so it won't be developed, it won't be clear cut. This in and of itself is pretty substantial to have right in the middle of an urban area, and the upstream connections, and potentially there are definitely opportunities for more work downstream of here before you get to the Rivanna. We could really have a remarkable corridor.